Hello everyone, so in this video my group will present it to you guys about linear function, which our group consists of Mary Andani, Veneranda, Charlie, dan Rian Hidayat.
Hello everyone, I'm here to conduct a function of linear. So, what is function linear? Actually, linear function is defined as a function that forms a straight line graph. A linear function is one that gets the highest rank of variability for simplicity. According to application of the linear function published by the Indonesian Computer University, a linear function is one that economists and business use all too often to analyze and solve economics problem. In mathematics, linear function is defined having one and two variables without exponential. It's a chart function for the straight line. In this case, if function contains more variables, then variables must be constants for perhaps the known variables for fixed function in the same linear states of function. For example, linear function here there is a linear picture.
Linear function formula. The expression for the linear function is the formula. To graph a straight line, the expression for the linear equation is y sama dengan mx ditambah c, where m is the slope, c is the intercept, and xy are the coordinate. This formula is also called slope formula. While in terms of function, we can express the above expression as f dalam kurung x sama dengan ax ditambah b, where x is independent variable. Linear function characteristic. Let's move on to see how we can use function notation to graph 2 points on the coordination. It is a group of ordered variable, a symbol that shows a quantity in a math expression. Linear function if its term is either a constant or it is the product of a constant and also the first power of a single variable, then it is called as an algebraic equation. Function. A function is a relation between a set of input and a set of permissible output. It has a property that its input is related to its one output. Steepness. The rate with a function deviates from a reference direction, increasing, decreasing, horizontal or vertical.
Next, the example. The first example is divided by two parts. Example 1, part A. The task is to draw a graph of a linear function fx equals 2x plus 4. The domain is greater than or equal to -2 and is smaller than 4 as integers or bilangan bulat. We'll need to make a table consist of x, f, or y, and x, y. In the x's row, we input the integers, and that is -2, -1, 0, 1, 2, and 3. In the fx rows, we input the results of the x in the linear equation. 2 times -2 plus 4 equals 0. 2 times -1 plus 4 equals 2. 2 times 0 plus 4 equals 4. 2 times 1 plus 4 equals 6. 2 times 2 plus 4 equals 8. 2 times 3 plus 4 equals 10. And now, why we didn't include 4 but we include -2? It's because the 4 is not equals 2, but -2 is equals 2. After we input the number and get these results of x and y, we could make the graph. X -2, y is 0. X -1, y is 2. X0, y is 4. X1, y is 6. X2, y is 8. X3, y is 10. And now we can make the graph, and these are the graphs. The next example, it's example number 1, part B. Now there is a difference between integers and real numbers. That's why with the same question we'll need to make the graph, but it's real number. The format is just the same and how we do it also the same. But the difference is if it's real number, we'll just need to include the limiting number and not the whole number in the domain. And that is -2 and 4. Even if 4 isn't equals to, we'll need to input this because in this real number, we only use the limiting number. So, angka pembatasnya, nomor pembatasnya, okay? We also make a table in the fx row and the results of the x in the linear equation. 2 times -2 plus 4 equals 0. 2 times 4 plus 4 equals 12. And then we can make the graph. X -2, y is 0. We put a circle that we filled, or we set a dot there. X4, y is 12. We put a circle, but we do not color it because in the domain it didn't say it's equals to. So that's why we didn't color it. It's just an empty circle. After we got the circle, we put a line between the circle. And this is the difference between real numbers and integers. One is with line and one is just dots. And next is example 2. Draw a graph of linear function fx 3 by 4x minus 2 with domain x is smaller than 4 and is a real number. We make the table and there's a 4 and a 0. Why is there a 0? It's because in the question it then says the other limiting number, and so we could pick the other limiting number that is smaller than 4. And why did I pick 0? Because it will make our job easier. So that's why we use 0. And 3 by 4 times 0 equals 0 minus 2, we got -2. 3 by 4 times 4 equals 3 minus 2, we got 1. And we could make the graph. X is 4, y is 1. Remember, because it's not equals to, we only drew an empty circle. And x is 0, y is -2. We drew a line and leave the line passes through the dot and is marked with an arrow because in the question there's no limiting number. And last but not least, example 3. It is known that the fx is 4 by 3 x minus 2 and the domain is x smaller than -2. This is real number. We need to find, does f intersect with x and y-axis, or apakah f memotong sumbu x dan y. First, we write down the equation fx equals 4 by 3x minus 2, and fx is y, so we can change it, and then we move to the x gradient variables to the left. That leaves us with -4 by 3 x plus y equals -2. To make it easier, we times -3 to remove the fraction, and that leads us to 4x minus 3y equals 6. We make the table. There's already a 0 on the table. X equals to 0. It will intersect y-axis, and y-axis to 0 will intersect x-axis. So we'll just need to input the number on the equation and count it. After that, we can make the graph. So after we see this graph, the answer is no, because it does not intersect with the axis, but only touch the axis. The easier way is just to look at the domain x and the x we got. If it's smaller than the domain, they will definitely intersect. But if it's bigger than the domain, it won't intersect. We got the x is 0 and the other x is 3 by 2. And it's bigger than the x in the domain. And that's all for the example.
So I'm gonna tell you guys about the implementation of linear function in economics and businesses. So the definition is the profit of a firm or company that makes on its product is the differences between the amount of its received from sales, which called revenue, and its cost. If X units are produced and sold, then we can write as the function of P of X, which is profit from sale of X units, equals to R of X, which is the total revenue from sales of X units, minus the C of X, which called total cost of production and sales of X units. In general, we can find the revenue is by using the equation of price per unit times of the numbers of the units. And for the cost, which composed by two parts, which are fixed cost and variable cost, which fixed cost is such as depreciation, rent, utilities, and so on, and that remain constant regardless of the numbers of units produced. And the second one is variable cost, which are those directly related to the numbers of units that they produce. So the cost equals to variable cost plus fixed cost. For the first example, let me show you guys. Mr. Kwon wants to open a boba stand in front of his house. The cost to construct the wooden stand and the business license that Mr. Kwon needs comes out to $5,000, and the cost to make each cup of boba is $1.25, and Mr. Kwon sold each cup for $3.75. So the first question is create the profit function for this scenario. With the basic formula equation that before, it's P of X equals to R of X minus C of X. Then we can enter the data from the question into the equation for the R of X, which are the price per unit, which are 3.75 times X, which the X we still don't know how much the units that sold, and it remains R of X equals to 3.75X, and for the C of X equals to the variable cost plus the fixed cost. For the variable cost, it's 1.25X from the price to produce each unit times the unit. And for the fixed cost is 5,000. So we can substitute the equation from above, which are the P of X equals to R of X. We can change it into 3.75X minus the C of X, which are 1.25X plus 5,000. So it remains P of X equals to 2.5X minus 5,000. For the second question, which is if Mr. Kwon sells 100 units, what will his profit be? So from the previous equation that we solved, which are the P of X equals to 2.5X minus 500, and we can enter the X as 100. So P of 100 equals to 2.5 times 100 minus 5,000. So it remains P of 100 equals to minus 4,750. Why it's minus? Because it means Mr. Kwon still isn't making profit or still minus. For the next question, which the third one, the last one, if Mr. Kwon sells 2,500 units, what will his profit be? So using the same equation from the A1, we can enter the X1 using the 2,500. So the P 2,500 equals to 2.5 times 2,500 minus 5,000. So it remains P of 2,500 equals to 1,250. So it means it's plus. So Mr. Kwon already making a profit. For the next question, a lawn service charge $60 per each lawn maintenance call. The fixed monthly cost of $600 includes the telephone service and the depreciation equipment. The variable cost includes labor, gasoline, and taxes, and the amount is $36 per lawn. So from the equation, we know that the fixed cost is $600 and the variable cost is $36. For the first question, write down the linear cost function representing the monthly cost, which are the C of X for X maintenance call, and write the linear revenue function, which representing the monthly revenue R of X for X is maintenance call. So the solving is C of X equals to 36X, which are the variable, which equation is the price produced per unit times the unit that produced plus the 600, which are the fixed cost. And for the revenue R of x equals to 60x. Why? Because the 60 is come from the price per unit and the x is the numbers of unit that we still don't know. And for the next question, which are the write a linear profit function representing the monthly profit P of x for x is maintenance cost. So using the basic equation, which are the P of x equal R of x minus C of x, and we can substitute the equation from the A1, which are the P of x equals to 60x minus 36x plus 600. So it remains P of x equals to 24x minus 600. For the next question is determine the number of lawn maintenance calls that needed per month for company to make money or make a profit. So for the solution of the third one is the word of to make money. So the result of P of x have to be more than 0. So using the equation that solve on the B1, the P of x equals to 24x minus 600 more than 0. And it remains x equals to 25. So what is 25 means? So it means on this point the company will get the profit if they reach more than 25 lawn maintenance calls per month. For the last question, the B1, if the lawn services make a profit of $384 in a month, how many maintenance calls that they were made? So the solution of the last question is we have to determine how much the x is using the equation from the B1 is P of x equals to 24x minus 600, and we can enter the P of x become the 384 from the profit that they want equals to 24x minus 600. So the equation is x equals to 41. So it means 41 calls are made for the profit of $384 in a month. So that's all the video presentation about the linear function from my group. Thank you and goodbye.